Hello, everyone. Welcome back to Scifun Academy, where science is made fun. This is part 4 of Chapter 1 Matter in Our Surroundings for CBSE Grade 9 Science. Today, we are answering a big question. Can matter change its state? Spoiler alert, it absolutely can. Let's dive in and find out how. Let's start with something we all know. Water can exist in three states of matter. It's a solid as ice, a liquid as regular water, and a gas as water vapor. But what is happening inside when water changes from one state to another? How does the change actually occur? Let's break it down. We'll start by looking at the effect of temperature on changing states of matter. When you heat or cool matter, its state can change. Recall from part 2 how temperature affects the kinetic energy of matter. Let's take a block of ice as an example. If you heat it, the kinetic energy of the particles inside the ice increases, making them move faster. As they vibrate more intensely, the forces holding them together weaken, and eventually the ice starts to melt. This is called fusion, which is just a fancy word for melting, really. The temperature at which a solid melts is called its melting point. For ice, this is 273 Kelvin or 0 degrees Celsius. Quick note on the Kelvin to Celsius conversion. Kelvin is the SI unit of temperature. This is the globally accepted international system of units. The relationship between Celsius and Kelvin is simple and linear. To convert Kelvin to Celsius, you simply subtract 273 from the Kelvin value. For example, 273 Kelvin is equal to 0 degrees Celsius. 373 Kelvin is equal to 100 degrees Celsius, and minus 273 degrees Celsius is equal to 0 Kelvin, which is called the absolute zero. This is the point at which all particle motion stops. But here's the interesting part. When ice reaches its melting point, its temperature stays constant until all the ice melts. Why? Well, the heat energy is being used to break the bonds between the particles, or in other words, overcome the force of attraction between the particles in the solid. This hidden energy is called the latent heat of fusion. So, what is latent heat? It is the heat energy required to change the state of matter without changing its temperature. The latent heat of fusion is the energy needed to turn 1 kg of a solid into a liquid at its melting point. Once the ice turns into water, we can continue heating it. At a certain point, the water starts boiling. That's when it changes from a liquid to a gas. This temperature is called the boiling point, which for water is 373 Kelvin or 100 degrees Celsius. The water doesn't just disappear, its particles gain enough energy to escape into the air as water vapor. The energy needed to turn water into vapor is called the latent heat of vaporization. The same amount of energy is needed to break the attraction between water particles and turn them into gas. Now, not all substances change state the same way. Some solids skip the liquid phase altogether and go straight from solid to gas. This process is called sublimation. A great example is camphor, whose force of attraction between its particles is weaker than other solids. At room temperature, these forces are able to hold it in the solid state, but with heat, they're easily overcome, allowing it to turn directly into gas. And while heating gives us fusion, vaporization, and sublimation, cooling gives us solidification, condensation, and deposition. Now, let's talk about the role of pressure in changing states of matter. Recall from part 3 that it is possible to compress a gas. That is nothing other than increasing the pressure on a gas, right? Increased pressure squishes the particles together and the gas turns into a liquid. This is how we store gases like LPG and oxygen in cylinders and even perfume in bottles by increasing pressure. What about dry ice? It is carbon dioxide stored under high pressure as a solid, and when the pressure is reduced to normal atmospheric levels, it turns back into gas without passing through the liquid phase at all. This is why solid CO2 is called dry ice. It doesn't melt into a liquid like regular ice. So, by changing temperature and pressure, we can control whether a substance is a solid, liquid, or gas. Pretty amazing, right? All right, it's quiz time. Let's start by converting the following temperatures from Kelvin to Celsius or vice versa. Okay, let's bring up the Kelvin to Celsius converter scale. 175 degrees Celsius is 175 plus 273 equaling 448 Kelvin. 398 minus 273 is 125 degrees Celsius. Minus 100 plus 273 is 173 Kelvin. And finally, 48 minus 273 is minus 225 degrees Celsius. Okay, next question. What is the physical state of water at the following temperatures? At 250 degrees Celsius, it is definitely gas or water vapor, since it is well above the boiling point of water. At 100 degrees Celsius, it is both gas and liquid. The water is boiling and turning into steam. At 25 degrees Celsius, it is just liquid. This is just room temperature water. And at 0 degrees Celsius, it is solid and liquid. The ice is solid and is in the process of melting into water. Question 3. Why does the temperature remain constant during a change of state, even though heat is being supplied? The temperature stays constant during a change of state because the heat energy is used to overcome the forces of attraction between particles rather than raising the temperature. This absorbed energy is known as latent heat, which allows the substance to change its state without a rise in temperature. Next question. Suggest a method to liquefy atmospheric gases. Atmospheric gases can be liquefied by increasing pressure and reducing temperature. Increased pressure brings the gas particles closer together, and reducing the temperature reduces the kinetic energy of the particles further, allowing them to condense into the liquid state. Okay, question 5. Why do naphthalene balls disappear over time without leaving any solid? Naphthalene undergoes sublimation, meaning it changes directly from a solid to a gas without passing through the liquid state. Over time, the naphthalene balls evaporate into the air as gas, leaving no solid residue. Question 6. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Ice at 273 Kelvin is more effective in cooling than water at the same temperature because it absorbs latent heat of fusion from its surroundings to melt into water. For example, if you hold ice in your hand gets cold because the ice is absorbing the heat from your skin. This additional energy absorption makes ice better at cooling than water at the same temperature. The last question. What produces more severe burns, boiling water or steam? It might seem counterintuitive to think that steam causes more severe burns than boiling water, especially since we can touch the steam above boiling water without much harm. However, the steam you touch has already come in contact with air and has started cooling down and partially condensed. This makes it less dangerous. The hot steam at 100 degrees Celsius or higher, however, carries extra energy in the form of latent heat of vaporization. When this steam condenses on your skin, it releases that extra hidden heat along with its temperature, causing a more severe burn than just boiling water. And that's the wrap on how matter changes its state. Here are some key takeaways from this lesson on changing states of matter. 1. Latent heat enables state change without raising temperature by breaking particle bonds. 2. Sublimation is when solids, like camphor, turn directly into gas without becoming a liquid. And 3. Increasing pressure can liquefy gases, as seen in LPG and oxygen cylinders. In the next video, we'll explore if we always need to heat or change pressure to change the state of matter, and discuss the final concept of this chapter, evaporation, and its real world applications. That's it for today's video. Thank you for watching. If you learned something new today or just feel smarter than you were 5 minutes ago, hit those like, share, and subscribe buttons and stay tuned for more mind blowing science. See you in the next one.